Let's welcome our next speaker, Willie Pretorius, who is the Soil Health Consultant at Ward Laboratories, Inc., to enlighten us on this subject. Welcome.
I actually don't know where to start because my previous speaker has covered a lot of the topics, and I will try and elaborate on some of the issues which he raised. Just to give you some background, I am an import from South Africa with a agricultural research background that transitioned to the management of several large-scale commercial cropping operations as well as agro-processing facilities. Here we go, thanks. I also happen to manage one of the largest fruit processing operations in South Africa, and in 2008, I basically returned to the academia of soil health, and I joined Ward Lab Laboratories last year as the soil health consultant. My exposure to the food industry has been largely instrumental in my interest of the topic that I'll be presenting to you: plant health, animal health, human health, and how that is connected to soil health. Plant health, animal health, and human health, and the connection to soil health how are these things connected? What is the significance of the topic? In this presentation, I will endeavor to explain the significance of the soil health on the human health and how the present high chemical input conventional agricultural system has destroyed our soils and how this decreased the mineral density and many of the nutritional quality issues that is grown on those areas. The correlating trends of increased non-pathogenic human health issues with intensification of chemical-driven crop production practices together with factory animal farm and animal production systems are raising red flags of concern in some quarters. These are, however, we must understand these are only correlating trends and therefore anecdotal and must be interpreted with great caution, particularly as disease identification technology is continuously improving. The fact that our food is decreasing in nutrition is, however, an undisputable, and some of the decreases can be explained as a result of the present high chemical input crop and animal production systems. In this instance, I want my audience to get some understanding of how the present day large-scale conventional agricultural driven systems is destroying our soils with a consequent inability to grow mineral dense and nutritious food. The correlating trends are a cause for concern, but we must not jump to conclusions. The undisputable fact is, however, that there is a dramatic decrease in the nutrient density and many other human health promoting substances, which I will try and explain to you how and why this happens. I will concentrate my presentation on this issue rather than trying to substantiate the human health issue, as I am not a medical doctor. One of the very obvious things which, and I think previous speakers have raised this topic, is that we are seeing an increase in the obesity of the human beings, not only in the US but all over the world. And one of the things which I think tells a great story is that the appearance of sport spectators in the last 50 years can tell you a story. If you look at sports spectators, in the 1970s, and you look at and you is it a different build, or is it, or what is the? It is to me very obvious when I walk into a large scale crowd. You do see a lot of people that are very, very obvious obese, and the one concerning thing is that it is. Crowds from the past and present confirms this analogy, and I'll also try to explain the reason why this is happening with the kind of food that is being produced. This is a slide that indicates the increase in incidence of non-pathogenic human diseases over the last 50 years, and I'm not going to try and elaborate on this. These are only given to you as trends in the presentation. So just to give you an indication of non-pathogenic disease increases as I don't want to say as a result of food, but people are starting to put this together in a way which makes sense, but I do not want to elaborate on that because this is not my area of expertise. But you can see the trends are very, very concerning. Now, just to get back to and to fill in where the previous speaker spoke about, what are the large-scale agricultural trends over the last 50 plus years? And there are several very concerning issues. The first one is the use of glyphosate. It is a herbicide that is causing some serious issues in human health, and I do not want to elaborate on that issue either because it is also becoming a very contentious issue. Then the increase of GMO crops, which is of concern. There's a real expenditure in the increase in the use of pesticides, and the other one is a use and possibly an overuse of fertilizers. Now, the use of glyphosate on GM crops, insecticides, fertilizers are common tools used by large-scale conventional agriculture, but you can see the trends are quite alarming. Are these trends a reason for concern? Not if they are used judicially, but the excessive use is certainly a cause for concern. The catch-22 situation over here, however, is that the incremental incremental soil degradation demands more and more of these to be used. The more the large-scale agricultural industry uses these tools, the more they need to sustain their production. The one issue that is of concern to me is that GMO seeds is largely facilitates the use or overuse of glyphosate, and the tragedy is that more and more weeds are becoming herbicide resistant, requiring higher dosages, with a consequence of superweed evolution, like the Palmer amaranth, for instance, which is a serious problem. So the more you use, the more the weeds are becoming resistant, and so it is an ever-increasing problem of you need more and more and more, and the term has been created that some of these farmers are called moron farmers. And an insecticide group, and this to me is a real concern. One of the insecticides known as the neonicotinoid group of insecticides. It's a seed treatment that, particularly used on corn, is taking a toll on our bee population very seriously. It is the third largest insecticide used in agriculture, and just to give you an indication that one treated seed has the ability to kill over 160,000 bees. Just one treated seed. That is a cause for concern, and we know what is happening to the bee population. Fertilizers are overused with serious environmental concerns, especially as it relates to our waterways. The effect of the large-scale agricultural practices I will try and explain in a few slides, and this is really an area of concern. What is happening to our soils? Just to give you an indication, the average prairie soil has been degraded over the years from an organic content of around 6% to 1.5%. And in our laboratory at Ward Labs, we rarely see nowadays an organic matter in excess of 1%, which is very, very serious. Soil without soil organic is dirt, and you can't farm on dirt. What are the causes? The causes are overtilling, agrochemical excess, monocropping, land fallow. Land lying fallow is a serious problem because soil is alive. Soil is an organism that, or it is the biota of organisms that drives the functions. And if those organisms are not fed, and the only way they can get fed is through growing plants. And if they're left fallow, you are actually killing the soil. The other one is overuse of fertilizers, which is excessive fertilizers. And then cropping, modern day cropping has become a recipe farming setup. So much so that many farmers are captured into a situation where big ag have their farms mapped through the technology that they have. They know exactly what they've planted. The salesman rocks up at the farmhouse and says, "Here's your recipe for the next year," and that's the way it's going. So the farmer is starting to be is captured within the system, and I think that is one of the problems that we have to try and get the farmers released out of such a system. The consequence of this is an ever decreasing spiral of problems with all the soil functions that nature has naturally provided decreases, and you need more and more and more to maintain the functions. The water infiltration decreases, your mineralization decreases, your water holding capacity decreases. So as nature's functions decreases, you are substituting the nature's functions with chemicals, and more and more and more with a higher and higher degradation, creating this spiral of complete degradation. Where did things go wrong so badly? Now, this is an area of great interest to me, because regenerative agriculture, in its true sense, is the use and farming with nature, and using the resources that nature provides in a way so as to benefit you on your farming operation. So we know that the atmosphere provides 4 of the most important components for that life is the building blocks of life: carbon, hydrogen, oxygen, and nitrogen, and those are all derived from the atmosphere and water. And the top 8 inches of an hectare of soil contains 1,000 tons of minerals and nutrients required for plant nutrition, macro, minor, and nano. And the nano is becoming a very important component of soil health, animal health, and human health. And I will elaborate on that in a few later slides. These are just to give you it's important to note that 96% of the building blocks required by plants, animals, humans are made up of only 4 elements. And this is carbon, hydrogen, oxygen, and nitrogen. And these are all in a nature situation derived from the atmosphere. Now, a lot of people may say, well, why have you got nitrogen there? Because in nature, the atmosphere contains 78% nitrogen, and it's the microbiology within the soil that has the ability to bind the nitrogen from the atmosphere into the roots. Now, the next comment that I will hear is, but that only happens with legumes. No, it doesn't. It happens with every single plant that's known to man. Your grasses, all your there are literally thousands of nitrogen-binding bacteria that assist with this. But as soon as you start applying more nitrogen to the soil, that bacteria component just diminishes in quantity, and you have to start adding nitrogen from a bag that actually originally created was captured from the nature through the process that was created by Liebig. 4% of the balance is 60 minerals that originates in soil. Those are the facts, but this is where things started going wrong. Because plants can grow, they can grow with only 13 of these minerals plus the 4 that comes from the atmosphere. So conventional agriculture has created the situation where these 17 minerals are what they're looking at, what they analyze, and what they use in supplementation. I compare that to building a house. It's like looking after the bricks, mortar, windows, and doors, and ignoring the little fuses, switches, hinges, and minor items that finishes the house. And this this is the important issue, because when we look at how conventional agriculture has developed with research over the years, we are applying a reductionist system. We are just looking at the research results and what it and the implication that it has on the crop production, without thinking about that this is part of a bigger system with a mass of different reactions taking place that needs to be taken care of to actually complete the house with all the little switches, the fuses, the air conditioning that's required. So this brings me to the next explanatory slide, where you can see there's 60 essential minerals. Now, you can see there that several of those minerals are almost unknown to many people. I have colleagues in this industry, like Dr. David Johnson, who's probably one of the most renowned molecular biologists that we have the benefit of working with him from New Mexico State, that actually says that it's more than 60. He thinks it's just about every one of the minerals that's contained in the periodic table. That's the extent to what people are starting to think about this, where we are neglecting hundreds or many of these because of the reductionist approach that we have in conventional agriculture. Now, the other very important thing to understand in this situation is that the minerals are the building blocks. It's like the bricks and mortar that you require for your house. And they are the building blocks that build but synthesize your vitamins, the other essential amino acids, and the essential fatty acids. Now, there's one component within that is classed as essential vitamins, which we are now, which we've moved out of that category, and we regard them as such an important component that we've put them on their own, and that's the flavonoids and the bioflavonoids. I've heard several presentations this morning about the lady who talked about her teas, the wine people who talk about their flavors. Those are the components that's required, that gives you the flavors within the food industry, where flavors are important, but mostly it is, you may have heard of the antibacterials, the anti-inflammatories, the natural anti-inflammatories, the natural antihistamines, the natural cancer components. These are all the chemicals that protect the human system against all the health hazards that is so rife at the moment. And what I've tried to explain to you is that when the biosynthesis of these molecules are inhibited, they are void in the food which we are eating. Now, just to put the cherry on top, one of the most important pathways within the production of your of three of your important essential vitamins, which is tyrosine, phenylalanine, and tryptophan. And this is the pathway that is blocked by glyphosate. So in plants and in microbes that that have this ischemic acid pathway. Glyphosate, that's how it works. It blocks the ischemic acid pathway that produces tyrosine, phyllene, alanine, and tryptophan. And the important thing about this is that the tryptophan, for instance, is a cyclic six-ring amino acid, and that is the precursor for all the flavonoids that I've talked about. So if you have a block in the system, either with a lack of a nanonutrient that is required as a coenzyme within the biosynthesis process that produces, there are literally thousands of these flavonoids and bioflavonoids. This is an area that is going to be heard of a lot more in human health, flavonoids and bioflavonoids. I'm fortunate to have the opportunity to work with Dr. Stefan van Vliet from Duke University, where we are doing a countrywide survey and looking at how soil health impacts those components. He has already put together several papers between him and Dr. Fred Provenza from Utah, are probably the top world's authority on the biosynthesis of these components. This is a vital and very important topic of human health. Just now to give some perspective to what's happening in plant breeding over the last 80 years. Obviously, the word that I hate the most in agriculture is the word yield, because I prefer to have the word yield substituted by the word profit. So what's happening in big ag? They are continually breeding for higher and higher yield, and they are breeding and selecting the new cultivars under higher and higher fertilizer regimes, which has the summarizing effect here. Over the last 80 years, maize grown side by side in Iowa and California, you can see the only component there that is increased is the starch, which is the bulk that gives you the higher yield. You can see what's happened to some of the biomarkers. The proteins have decreased, the natural oils have decreased. Lysine, tryptophan, which is one of the most important component as a precursor for your phenolic substances, methionine. These are all in fruits and vegetables and grains. 80 to 90% of the dry weight yield is carbohydrate. When breeders select for higher yield, they are selecting mostly for high carbohydrate, with no assurance that dozens of other nutrients and thousands of phytochemicals, which all increase in proportion to yield. Thus, there's a dinetic dilution, which is not unsurprising. So, we talked about obesity. So, your body now, in order to, and the next slide will actually elaborate and substantiate what I'm trying to get across over here, is that your body, in order to get the essential nutrients, needs more and more and more of the carbohydrates. So this could be a reason for natural obesity occurring in populations. In most instances, as I've said, it's selected under higher fertilizer regimes, and here's the crux. And one of the areas which I'm passionate about is, as soon as you start losing the connectivity between between the crop and what I call the mineral nutrients. There's a natural connectivity that takes place through mostly fungi and a particular group of fungi called the mycorrhiza that absorbs the nutrients. And the next slide will explain it in more detail. Can I just go back? Okay, this gives you an indication of how. This is just an overview of illustrating what the difference is in the conventional chemical system with the biological chemical system. How plants absorb their nutrients and what is the huge difference in a chemical system. It's an active absorption where the nutrients will only be absorbed when it's in the soil water, or when a root comes into contact with it in the soil, in the soil water phase. In the biological system, the mineral access is through an intelligent fungal attachment to all minerals required with bacterial-based assisted solubilization. What this entails is that your roots, you can see it extends the fungal communities, the mycorrhiza extends the roots by literally thousands of kilometers. And it actually attaches to the minerals that's within the soil of all the different chemical components, be it a nanonutrient that is required by the plant, and there's a signaling system happening between plant and the fungal and other bacterial components, indicating that I need a little bit of magnesium, I need a little bit of zinc, I need a little bit of cobalt, and this is how nature works. So you have this system where the plant actually is able to absorb all of its required nutrients to provide the vital and natural and healthy food. Whereas in the reductionist system, where we are only looking at about 17 minerals, that's what's provided. So you can see what the difference is in the content and quality of the biochemical processes that happens in the plant. So there are so many blockages that you do not get all the healthy components required for good human health. Let's just look at essential fatty acids and grass-fed and grain-fed beef, a topic of also extreme interest and a lot of discussion around this lately. Let's just look at the facts. When you look at the fatty acids, of which your omega-3s to omega-6s, omega-6s to omega-3 ratio is the important one. You can see that a healthy diet is about a 4-to-1, and an average, and you can see it goes up to about a 30 ratio in the average American diet. Now, just some background of the relationship between human health, omega-3 and omega-6s. Human beings have evolved eating a diet of omega-6s to omega-3s over the centuries in a ratio of 1-to-1. This is the natural animals, all the natural meat and nuts and food that was eaten over the earlier years had this kind of ratio. Modern Western diets exhibit an omega-6 to omega-3 ratio of between 15 to 17. I've seen analysis as high as 50. Exceptionally high omega-3 to omega-6 6 to 3 ratio is associated with development of chronic diseases. And a ratio at average of 4 to 1 is associated with 70% reduction in mortality in secondary coronary and heart disease prevention. I think that's quite common knowledge nowadays. Just something, grass-fed and grain-fed beef. We have there in the first one a typical grass-fed beef meat, and in the second two, the 12 to 1, 17 to 1 are two grain-fed beefs out of a feedlot situation. Now, just very important that grass-fed beef, as Dr. Fred Provenza says, grass-fed beef is not grass-fed beef, it's not grass-fed beef, because there's also a difference in the quality and in the composition of the omega-6 to omega-3, depending on the diversity of grasses and herbs and that your cattle consume. This is very, so diversity is the name of the game in regenerative agriculture. Then just to complete the picture, you'll see that the phytochemicals I spoke about, once again, as the diversity of the grass pasture on which these animals are raised, so does the increase in the phytochemical richness of your meat and your milk also increase. Just a closing remark. What is the food industry doing about this? Food industry uses crops grown from many agricultural systems, but are they taking note of the nutrient content? Are they testing for nutrient density? Large food companies, and this was mentioned by the previous speaker, Danone, Cargill, McDonald's, Target, and others have taken the lead in encouraging and assisting their farmer suppliers to become regenerative in their farming practices. And General Mills has got, I think this statistic was also put up, has put in place several pilot projects, particularly in Kansas and in North Dakota and in Canada, grouping farmers together in certain areas with target acreages under regenerative cultural practice by a certain target date. And they've targeted 1 million acres. This number was mentioned by the previous speaker of having a million acres by the year 2030. Ward Laboratories extends an invitation to the food companies requiring assistance to get their farmer supplies more regeneratively orientated to contact us, as we have all the soil health analysis services together with the knowledge and consultants that could persist with this process. Thanks for listening to my presentation. I'm available to assist with all of these issues. Thank you.